Hello, and welcome to this module on hacking web applications. Let's see what we'll be covering in this video. We'll start with web application vulnerabilities, and then we'll move on to the different web application attacks, and then we'll go on to the impact of these web application attacks, and finally we will end off with countermeasures against web application attacks. Let's get started. Before we move on to some examples of web application vulnerabilities, I'd just like to take the time to just emphasize that web application hacking or hacking web applications is a huge and very vast field in penetration testing, to the extent that a lot of people actually specialize in web application vulnerabilities. Because it is so vast, it's almost impossible to cover every single kind of vulnerability that's out there. So in the slide, I've just chosen the top 9. There's a organization called OWASP. If you go to their website, every couple of years they give you the top 10 vulnerabilities for web applications, and I highly recommend that you do that. But let's start and let's see what we've got. First and foremost, cross-site scripting. So cross-site scripting is pretty much an attack against the end user, and what it does is it allows a malicious actor to embed a malicious script on a website, usually in the comment section or in somewhere where the user can add some form of data. And when somebody goes and visits that actual page, they are then redirected in the background with a malicious script. And we'll see an example of that in the demo later. Then we have information leakage. Now, information leakage is a very broad topic, but an example of a web application vulnerability is not turning off the debug mode when you move your web application from development into production. So what would happen then is if the application throws an error, the full error message is disclosed to the end user, and you wouldn't really want that, because your full error message may contain things like the database name, the type of database, what applications are running, the file structure of the system, etc., etc. So if users don't need to know that information. In fact, it is highly recommended that you keep that information private, because it does make compromising a web application that much easier. Weak authentication is probably one of the biggest attacks. So a lot of the celebrity hacks that you've seen over the years, that literally just comes as a result of people guessing passwords. That's actually, at the end of the day, what is probably the low-hanging fruit. The easiest way to get into a web application is to pretty much guess a username and password. And we'll see an example of that in the demo as well. Cross-site request forgery, similar to the cross-site scripting, but it pretty much is more on the server side. And then predictability of secure interfaces. So what do I mean there? So a very good example is WordPress. So WordPress, if you want to go to the admin page and log in as an administrator, you literally just in the WordPress site URL, you put /wp-admin. So now everybody knows that that is the literally the front door to WordPress, and a lot of scripts out on the internet will automatically try and brute force that. So as soon as you put that out there, they will start trying to brute force and guess the password. So the right thing to do there is pretty much change that default URL, the secure interface, that wp-admin, change it from wp-admin to something else. And there are plugins and code that can do that for you. Same with Joomla, same with Drupal. You need to change the predictability of the secure interfaces. SQL injection. Well, SQL injection is pretty much taking advantage of a vulnerability in the SQL validation and exposing SQL data or data from the database directly into the browser via a very cleverly crafted script. There's an entire module on SQL injection, so we won't be covering it in too much detail here, but understand that that is one of the web application vulnerabilities that exist. Insecure session handling, as per the module on session hijacking, I think it was covered in detail there, but it's pretty much making sure that the session state between the user and the server is secured, it's encrypted, and that your cookies and session IDs, etc., expire frequently and are very difficult to guess. That's pretty much insecure session handling as per the session hijacking module. Then we have poor development practices, and pretty much what happens here is the there are lots and lots of applications being developed by web application developers, both mobile apps, web apps, things that run on the desktop. Anything that runs on the internet is more or less a web application. And the state of the industry is such that people are in such a hurry to get these applications out there that security is always an afterthought. And that's why we say poor development practices actually lead to web application vulnerabilities, because if they took the time and security was done up front, there would be a lot less poor development practice applications out there. And that's where the role of the penetration tester comes in, because that person is trained to look for vulnerabilities that aren't local or globally known, because it's very relevant to that specific application. And that's where penetration testing becomes very useful in web application vulnerabilities. Okay, and then finally, not validating untrusted data. So basically, if you have a form on a website, if you have anywhere where the user is going to be inputting information, that data must always be seen as untrusted. In other words, you can't just write that data directly into your application, directly into your database, directly onto the file system. You need to validate it. You need to make sure that the data doesn't contain any scripts, it is what it's supposed to be, and if it's a username with an email address, it must be a username and email address. It mustn't have some form of code or etc. in there. So any form, and that's a very key concept to understand, anywhere in an application where a user is putting in data, that data should be seen as untrusted and it must be validated. That in itself will take away a lot of web application vulnerabilities affecting user input. Let's move on and look at the different web application attack techniques. The first technique we want to talk about is denial of service. And as per the module on denial of service, this is a very popular technique to take down large websites and pretty much making them unavailable. And there's a whole module on denial of service which we've already covered, which shows you the different techniques used by attackers to attack web applications via denial of service. SQL injection we've also covered in the vulnerability section, and there's another module coming up which is purely dedicated to SQL injection. But as per the previous slide, it's basically making use of unvalidated data that then runs a SQL script which presents data back to the user in the browser. Brute force login, we've used that, we've also discussed that in the passwords module, and that's basically guessing usernames and passwords, and we'll see another example of that in the demo that's coming up. Then there's cross-site scripting, which we've also discussed in the previous slide, and that is a user attack where you're using malicious scripts to redirect users to another malicious site or to steal their cookie or whatever it is. Cross-site request forgery we've also covered, and it's pretty similar to cross-site scripting except that it is a server-side attack. Form tampering we've discussed very briefly in the vulnerability section, and that is where people pretty much put untrusted data into a form, and by manipulating the different fields of the form can make the application act in an erratic way and sometimes cause a vulnerability to be presented to the attacker. Then we have a buffer overflow, which is also covered in the module on web server attacks, and it's basically making use of poor memory allocation in the application, which then makes the application act very erratically and in some cases allows you to execute remote commands using the memory overflow. Poor error handling we also discussed in the vulnerability slide, and that is where pretty much moving sites from development to production, leaving the debug mode on and allowing the attacker to actually get a whole bunch of information because the errors aren't being handled correctly by information disclosure. Another form of poor error handling is buffer overflow, where the application throws an error but creates a vulnerability in the process. And then finally there's session hijacking, which we have covered in the previous module. As you can see, there's quite a matchup between vulnerabilities and attacks, and they pretty much have the same name. And that's because web application penetration testing is pretty much matching vulnerabilities, and the attacks that match those vulnerabilities are pretty much named the same way. And you'll see a lot of those out in the field, and there's some really excellent books and tutorials and courses on web application penetration testing, because it is such a large field. You have to pretty much go into every one of these, and each one of these application attack techniques is a course on its own. Let's move on and look at the impacts. So the impact of web application attacks is pretty much the same as the web server attacks. It's in fact, it's exactly the same, because you'll have reputational harm. Your site will go offline, or data will be exfiltrated and you'll be embarrassed, or you'll be sued by people. So there's always reputational harm, because you are attacking a public-facing service of the organization. There's defacement, which is also part of the web server application attack impacts, because once people have access to the application, they can upload messages and deface the website or whatever it is. There's data theft. You can exfiltrate a lot of data from a web application, especially where subscriber data is stored, and sometimes people store passwords in clear text, which they shouldn't. Is a good example of that. And then the problem with that is that people usually reuse passwords. So if you have a username and password combination, you could then go test that username and password combination on another site. That is why it's so important for everyone to look after passwords, and not only the big sites, because people do reuse their passwords. Malware servicing. If you have access to the application and you can change the code or the HTML or the JavaScript on the page, well, guess what? Then you can pretty much introduce some form of malware. You can maybe upload a Trojan to redirect people to another site where viruses or worms can be pretty much infecting their machines. And then finally, there's web server compromise. So we gave an example of that in the web server attack, where the actual web server was very well hardened. It was very secure, but the application was very poorly secured, and as a result, the attacker could actually get full root access to the web server. We'll see another example of that in the demo coming up. Let's move on and look at the countermeasures. Now, just as with the web server attacks, the web application attack countermeasures are pretty much the same. First and foremost, you must patch your application. If a new version of your WordPress comes out, you must update it, because guess what? All the attackers out there are looking at the software vendors, and when the software vendor releases a patch, they can say, okay, well, now we know for sure that the previous version had a vulnerability, and sometimes the vulnerabilities are disclosed, so it's pretty much a race in time. You need to patch your system before the attacker can attack you. Then there's software hardening, pretty much the same as server hardening, but if there's certain application features that don't need to be enabled, then guess what? They shouldn't be enabled, because you're just limiting the attack surface. Vulnerability scanning. As with the web server attack, we're going to scan vulnerabilities in web applications, and you get specialized web vulnerability scanners, and we'll see an example of a WordPress vulnerability scanner in the demo that's coming up, which shows you, it looks at your WordPress install and then lists all the issues that there are so that you can fix them before the attackers do. There's also application software and hardware web application firewalls, which are similar to normal firewalls, except they do layer 7 filtering, and these can also be outsourced to third parties. So in other words, you can filter all your traffic through web application firewalls, and a web application firewall pretty much resides with your web application and controls access to the web application. So it's a measure over and above a normal firewall. Then we have restrict remote administration, as always, and we discussed the changing of the WP admin URL for WordPress. But also, if you have Joomla or Drupal, just try and obfuscate, hide the URL, change it to something that only you or your customer needs to know, because you will be restricting the remote administration of that site. Change default settings. That goes without saying. If your application has a default admin username and password, please change it and make sure that it's changed before you move it into production. This isn't such a problem these days, but it still does exist in a lot of older applications that are out there. Penetration testing. is definitely a very worthwhile investment in web application countermeasures, because the penetration test is trained to look for vulnerabilities across all applications. So especially custom developed applications where, for example, something like Metasploit won't have an exploit for it because it's literally a unique application. A penetration tester would be able to, or should be able to, find a vulnerability and write an exploit for you so that you can patch it before it actually gets attacked in the real world. And then finally, constant vigilance. As with the web servers, your web applications must be monitored. You must check your log files. You must make sure that your web application firewall logs are also checked, and ensure that your web application is as secure as it possibly can be. And this is an ongoing thing. You can't do it just once and then leave it. You will need to constantly be measuring the vigilance and measuring the security of your web application. And that pretty much ends this video. Thank you for watching.